The following question is about polymerization. The question reads that the table gives some statements about some macromolecules. So polymers are large molecules, and the question is that which pairs of statements are correct. We need to figure out the. So if you look at the first statement states that fat contains the linkage which is given as C double bond O, and O is called the ester linkage. And the other statement is that proteins contain the linkage which is shown over here. This is called the amide linkage. So this statement is true, and let me show you a molecule of a fat and of a protein. So I've drawn this fat molecule over here, and as you can see, it's a complicated fat molecule. But notice that there's a C double bond O linkage, a C double bond O making a single bond with O. So fats have this linkage, which is this C double bond O followed by a single oxygen. So this ester link is present in fat molecules. And over here I have a protein molecule. A protein molecule is made up of many different tiny amino acids, and all protein molecules have this amide linkage where you have a C double bond O followed by a nitrogen and a hydrogen. So you can see that this link C double bond O and in H is continuing. So this link, which is called an amide or a peptide link, is always present in proteins. So this linkage is present. So coming back to the question, so the first statement that fats contain the ester link and proteins contain the amide link, this statement is correct. So this first statement is correct. Looking at the second statement, which is that polyethene is made by addition polymerization and terylene is made by condensation polymerization. So I'm going to discuss the second statement now. So I'm going to first discuss polyethene. Remember, polyethene is made from ethene, which eth stands for 2 carbon atoms and ene stands for double bond. So polyethene has a lot of ethene molecules, and they would be bonded together to form a very large macromolecule or a polymer. So I'm drawing multiple ethene molecules. So let's draw at least 4 ethene molecules. So that's my third ethene molecule, and let's have another ethene molecule. Remember, polyethene chain would contain roughly thousands of different ethene molecules. So this is a very simplistic version. Now what happens is that under high pressure and temperature, the double bonds break. So I'm going to remove all the double bonds, and they get converted into single bonds. So all these ethene molecules, they lose their double bond, the pi electron cloud, and it breaks up to form a molecule. Now carbon is short of 1 bond. If you look at these carbon atoms, they're making 3 bonds instead of 4 bonds. Each one of the carbon atom is making 1 less bond. They should be making 4 bonds. So what they start doing is they start bonding with each other, and they start linking up. So when they start linking up, a polyethene, because all the ethenes got added up, so a polyethene molecule or a macromolecule would be formed, a very long chain consisting of many different ethene molecules or monomers. They end up joining together. Now you can see all the carbon atoms are making 4 bonds. So to complete the 4th bond, they started linking with each other. And this is an example of addition polymerization, because all of them simply got added up. So this is addition polymerization, and it's an addition polymer. The second statement was about terylene. Now terylene is a synthetic polymer that is formed from 2 monomers. One monomer would have, so there's going to be a box which could be anything. This box represents a molecule which has carboxylic acid functional groups on both sides. So it's a dicarboxylic acid molecule. So this is one of the monomers. The other monomer is going to be a molecule that has OH, or it's a diol that has OH functional groups on both sides. And these monomers are going to repeat in tandem. So again, followed by C double bond O and OH, a dicarboxylic acid. This box could be any simple molecule, acetyl bond O and OH, and then followed by a monomer of a diol, which will have OH on both sides. And what happens is, this is an example of condensation polymerization. In condensation polymerization, water is removed. The carboxylic acid ends up losing its OH and the alcohol ends up losing its hydrogen. So all these carboxylic acid, the alcohol loses its H. Again, the carboxylic acid loses its OH, the alcohol loses its H, the alcohol loses its H, and it keeps on continuing on both sides. So thousands of different monomers, they link up. And now I'm going to remove all the water molecules. All of these, they end up forming H2O. The H and OH, they get together, which is why it's called a condensation reaction, because water is produced as a byproduct. So water is removed in each of the linkages. So now I've removed the H and OH, and each of the atoms is now short of one bond. So they start linking up with each other. The acetyl bond O links up with the oxygen. So they all start linking up with each other, and this continues on both sides, and a very long chain. So this is an example of a condensation polymerization. So this is a condensation polymer as water is produced. And terylene is an example of a polyester, because these ester groups, there are multiple ester groups being formed, so it's a polyester. So coming back to my question, so the second statement is also going to be correct. Polyethene is made by addition polymerization, and terylene is made by condensation polymerization. Now moving to and we can also moving to the third statement, that is, a starch can be hydrolyzed to produce sugar, and proteins can be hydrolyzed to produce amino acids. So let's look at this third statement now, that starch can be hydrolyzed to produce sugars. Now remember this, the starch is a form of condensation polymerization, and its monomers are sugars. So this statement is correct, that if you break down a starch molecule, a polymer of starch, sugars would be produced. And similarly, proteins are made from amino acids. So if you hydrolyze a protein, is also a condensation polymerization. It's formed by condensation polymerization. So hydrolysis has to be done to break it up into smaller pieces, amino acids. So this statement is also true. This third statement is also true. This fourth statement is incorrect, because terylene is not a naturally occurring polymer. This statement is incorrect. It's a synthetic polyester which is used in fabrics. And nylon is a man-made polymer. This is correct, because nylon is used in ropes. It's a man-made polymer. But only one part, not both statements are correct. So this fourth statement is not, the pair of statements are not completely correct. One is correct, one is incorrect. So the correct option for this question is going to be option D, because only the first, second and third pairs of statements are correct. The fourth, there's one statement that's incorrect.